All right, let's jump right into it. Think about the millions of cars, trains, and planes moving around every single day. How does that all work without turning into complete and utter chaos? Well, that's the magic of transportation engineering. In this explainer, we're going to break down all the core concepts from Chapter 1. Think of this as your ultimate study guide to help you ace those exams. Let's get started. So let's kick things off with a question you're almost guaranteed to see on a test. What are the 5 core components of a transportation system? It seems simple, right? But trust me, this question is the key that unlocks everything else. Keep it in the back of your mind, because by the end of this, you're going to know the answer cold. So, to really nail that question, we've got to start with the fundamentals. What even is transportation engineering? You're probably thinking about roads, bridges, that sort of thing, but as you're about to see, it's so much bigger than that. Okay, so here's the textbook definition. And yeah, it sounds a little academic, but zoom in on those 4 keywords: planning, design, operation, and management. At its heart, transportation engineering is all about using science and tech to move people and things around safely and efficiently. That's really the big idea. And this diagram right here, this is the key. It shows us something absolutely fundamental. Every single transportation system, I don't care if it's your local bus route or a global shipping network, is built from these same 5 core parts. Getting these 5 down is how we're going to answer that big question. Let's break it down nice and simple. First, you've got your modes. That's just the vehicle. Your car, a train, a plane. Easy. But those modes need something to run on, right? That's the infrastructures, the roads, the tracks, the airports. When you connect all those points, you get networks. And what's moving on these networks? That's the flows, which is just a fancy word for people and cargo. And finally, to make sure it all works, you need a control system. All the rules and tech like traffic lights, air traffic control, and railway signals. So, one more time. Modes, infrastructure, networks, flows, and controls. Boom, there's your answer. Okay, so now we know what a transportation system is. But what do transportation engineers do all day? I mean, what's the actual job? Well, the field is huge, so let's look at some of the major areas you could actually specialize in. Imagine you're building a new high-speed train line. The transportation planners would start by trying to figure out how many people might ride it, like 20 years from now. Then the geometric designers get to work, mapping out every single curve and slope of that track. Pavement engineers design the super strong foundation it sits on. Traffic engineers figure out how this new train line connects with all the existing roads. Of course, the environmental team makes sure the whole project is sustainable. And then you have ITS, or Intelligent Transport Systems. That's the cool modern stuff, like the app on your phone that tells you exactly when the train will arrive. Now, engineers work with all these different ways of getting around. So which one's the best? Is it a car? A train? A plane? The answer, and this is always the answer in engineering, is it depends. Every single choice is a trade-off between things like speed, cost, and how much you can carry. This next slide makes that crystal clear. So check this out. Road travel, it's super flexible. You can literally go from your front door to any other front door. But for long distances, it gets pricey. Rail is a beast for moving heavy stuff across the country, but man, the cost of laying all that track is huge. Air travel, nothing is faster. But it's the most expensive, and a little bad weather can throw everything off schedule. And finally, water. It is by far the cheapest way to move massive loads, but it's also the slowest. The real genius of an engineer is picking the right tool, or combination of tools, for the job at hand. You know, to really appreciate just how far we've come, we've got to look back at where it all started. The challenge of building a good road is basically as old as civilization itself. And some of the solutions from way back when were so brilliant, they actually still influence how we do things today. People have been paving roads since around 3500 BC, but it was the Romans who really turned it into an art form. For them, it was all about military power. They needed roads that would last forever. Fast forward a few centuries to the 1700s, and guys like Pierre Trezeguet in France start refining the process. But the real game changer, the guy who made modern road networks possible, was John Macadam in the 1820s. I mean, just look at this. This is a cross-section of a Roman road. It wasn't just some rocks thrown on the ground. It was a seriously complex system. They would dig a deep trench, lay a foundation of huge stones, add more layers of compacted gravel and cement, and top it all off with massive paving slabs. They even sloped the surface so rain would drain off. It's no wonder some of these roads are still around today. This comparison tells the whole story. On the left, you see the Roman way, incredibly strong, built like a fortress, but also incredibly expensive and slow to build. On the right is Macadam's big idea. What he figured out was just genius.
The dirt underneath can handle the weight, as long as you keep it dry. So his roads just needed a thinner, waterproof layer of compacted, angular stones. This was a total revolution. It made road building way faster and cheaper, and that's what made our modern road networks a reality.
Okay, so we've got the components, the different jobs, and the history. But where the rubber really meets the road, pardon the pun, is in planning for the future. A country's entire development, its economy, its society, it is all directly tied to how well it plans its transportation. And good planning isn't random, it's structured, kind of like a pyramid. At the very top, you have the national plan. These are the huge highways, the main arteries of the country. Feeding into those are the regional plans, which connect major cities and areas. And at the base, you have the local plan, which makes sure every little town and neighborhood is connected to the bigger system. It's a top-down approach that makes sure the whole thing works as one giant connected machine. And remember, planning isn't just about drawing lines on a map. It's about hitting very specific targets. Planners are always in a balancing act, trying to make traffic safe and efficient while keeping costs as low as possible. They have to be part fortune teller, predicting future traffic needs, and part accountant, figuring out who's going to pay for it all.
And that brings us to another question you might see on an exam. This one looks a little intimidating, right? But wait, look closer. It's asking about the classification of roads. We just talked about the planning hierarchy: national, regional, local. Those are classifications. See? The stuff you've just learned is exactly the foundation you need to tackle these big, complex questions.
So there you have it. You now get the 5 core components of any transportation system. You know about the major disciplines, the trade-offs between different modes, the history from Roman times to Macadam, and why planning is so absolutely critical. These are the fundamental building blocks of everything that follows. Because in the end, transportation engineering isn't really about asphalt and concrete. It's about connecting people. It's about creating opportunity. It's about building the future. The networks we design today will literally define the world of tomorrow. The real challenge and the real test for any engineer is making sure we plan them wisely.